By looking at this function, this original function, y equals, how do I know that using quotient rule is not going to be the most effective way of finding the derivative?
Oh, because you can do the original power rule.
Why?
You can multiply them by x squared plus 3x times 1 over 6.
Okay, we could do that. That's one option. So bring the divide by 6, take it as 1/6 times that x squared plus 3x. What else? I love quotients that have one term in the denominator. I can split it up, right? 6, 6. That's pretty easy too. So that's one way to do it. It's up to you if you want to make it 1/6 or if you want to break it up into a fraction, two fractions, both over 6. That's up to you also, okay? Rewrite, and I think some of your problems, again, are just going to walk you guys through, scaffold some of the rewriting. We'll start out maybe some easier problems. I'm going to make this 1/2 x. Is that okay? Or 1 over 2x? Or x over 2, I mean. And then derivative. What is that going to be? Okay, we'll go 1/6 times what? 2x. Okay, and then plus derivative of 1/2 x. 1/2. Okay. Simplify real quick. Y prime equals, what is that? 1/3 x, or x over 3 plus 1/2. And this would be a quadratic function. The derivative should be linear. Okay, any questions on this? Obviously, you can break these up any number of ways. Part B, though, looks like to me maybe distributing and breaking up, I think would be probably the way to go. We might need 2 rewrites, so I'll start right here. And again, when you're rewriting the function, you're not taking the derivative yet. Okay, what was that? Negative 9x over 7x. Can we do that right away? Plus, then that'd be what? Positive 6x squared over 7x. X's divide to 1, so we have negative 9/7 it looks like. And then 6/7 x. This factor takes care of one of those. It's not too bad. All right, y prime then would be just 6/7. Yeah, I'm going to simplify that. That's pretty easy. Okay, so keep in mind when it tells you guys just to differentiate something, find the easiest way possible, right? Choose the easiest method. Derivatives of trig functions, we're going to develop them, then you'll get the answer, and then yes, you should memorize it. I want you to be right away, say derivative of tangent is, and I want you to say like instantaneously. You got to know those, okay? Again, I think it'd be a good idea if you guys go through things, and every time I say you got to memorize this, make a flashcard. Take a card, write it down, and then just build that deck of cards, and you can go scroll through every once in a while and just refresh your memory. It does help. All right. I have no idea what this is, but I do know that we can rewrite tangent as sine over cosine. Remember we said when in doubt, sines and cosines, right? Ooh, now we have a fraction, though. We have a quotient. We have a quotient rule. Well, the derivative of that quotient is going to be, let's see here, low, which is cosine, d high, what's the derivative of sine? Cosine? Yes.
So
Minus. D low, what's the derivative of cosine? All over cosine squared. And remember, cosine x, quantity squared, we could write that as cosine squared x, okay? All right, it was cosine times cosine. Okay, we have negative times negative, so that'll be positive. Sine times sine, sine squared. And then that will be cosine squared. All right, is there anything else we can simplify that you guys see? Yes, ma'am. 1 over cosine squared. Yes, cosine squared plus sine squared is 1. Remember, we're trying to make things as simple as possible.
What if you just cancel?
What do you mean cancel? See this guy right here?
Yes, I see it now.
This means you better factor before you cancel, right?
Right.
Mm-hmm. All right, 1 over cosine squared. Is there a better way to write that? What's reciprocal cosine?
-1. Oh,
That's still complicated. That's negative. What? Yep, secant squared. All right, this is better than the 1 over cosine squared. So, derivative of tangent is secant squared. There we go. Okay, let's find the derivative of secant. Okay, we don't know what it is, but we do know we can rewrite secant in using sines or cosines. So d dx. Secant would be 1 over cosine, I believe. Ooh, now we have to use the quotient rule with this. Okay, low cosine. D high. Derivative of 1. That's the people there want to argue. You guys want to, what is it? 0. Minus high. D low. All over. Cosine squared. And we could write cosine squared x also, but I'm going to write like this. All right, multiplying by 0. I love that. Negative times negative positive, so we have sine x over cosine squared. I'm going to write it cosine x squared again. The reason why, because this is a derivative, guys. This is a derivative, but it's a fraction still. Let's try and write things not using a fraction. Well, we can break this up. Okay, that'd be what? Sine x over cosine x times 1 over cosine x. And honestly, I probably should have wrote it the other way because I'm going to show you what the derivative is, but okay. What's sine over cosine? What's 1 over cosine? And actually, I'm going to write it as secant x tangent x because derivative of secant is secant tangent. I think it's easier to memorize it that way. That's 2 of the 4. Cotangent. All right, what is cotangent as sines and cosines? So 1 over tangent, therefore it would be
1 over sine over cosine.
cosine over sine?
Also 1 over sine over cosine.
That's way too much work for a Friday, Jacob. All right, low, d high, derivative of cosine, negative sine. Okay, minus high, d low, cosine. Okay, you guys see how yesterday I was actually writing d dx of that low and of that high, and now we're just finding the derivatives. I think we're there, we're fine. Okay, sine x quantity squared. Well, that looks like to be negative sine squared. That looks to be negative cosine squared of x. Sine squared x. Oh man, it's negative sine squared minus cosine squared. I wish it was positive positive. Yeah, factor negative out. You guys kind of getting used to my verbal cues sometimes. All right, so that means sine squared plus cosine squared is equal to 1. That means we have negative 1 over sine squared x. And what is the reciprocal of sine squared? Yep. So the derivative of cotangent is negative cosecant squared. Okay, one more, right? Derivative of, oh, I think there might be a pattern here. Okay, derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. Derivative of secant is secant tangent. What do you think the derivative of cosecant is? Anything else? Let's see if it's right. All right, d dx. What would that be as sine or cosine? All right, quotient rule. Low, which is sine. I'm sorry. Yeah, sine x. Jeez, I was thinking ahead. Low, which is sine of x. D high minus high. D low. All over. Sine x squared. Okay, good. And then, okay, multiply to 0. We got negative cosine. Well, we've kind of done this before. You guys okay if I go over sine? And then 1 over sine also? Break up that sine squared x into two factors. If we multiply these two fractions together, we get that. All right, what is negative cosine over sine equal to? What is 1 over sine equal to? All right, and just like before, I'm going to write this differently. Negative cosecant cotangent. So derivative of cosecant is negative cosecant cotangent. Not too bad. You guys developed all the trig derivatives. Here you go. Here's those 4 derivatives. And if you want to add the other 2 trig derivatives in this spot, well, we know that derivative of sine is equal to cosine x. And then the derivative of cosine is negative sine x. Now, there is one particular thing that I had to remember. I was getting the negatives mixed up when I was first learning about derivatives. If we're taking the derivative of a trig function that starts with c, the answer is negative. Right, does that make sense? I was really confused on which ones were negative or not back in the days, and I saw there's a pattern, so then it helped me remember it. Okay, these ones do not start with c. The derivatives are positive. Definite pattern. Sines and cosines go together. Tangent, secant goes together. You'll see that a lot. Secants and tangents go together. Cotangent, cosecant, and then secant is 2 and cosecant is 2. Y prime equals, what's the derivative of x?
1.
Minus, what's the derivative of tangent x? Secant squared. All right, what about this one? Be extremely careful. Remember, look at your function, analyze what's going on, identify operations, what's going on here. Look at the function, ask yourself, what's going on here? What do I see? Product. You gotta use product rule, okay? First function, second function. They are going to sneak x's or something else in front of the trig function, and a whole bunch of times people just go 1 times secant tangent. Nope, it's the product rule, guys. Okay? All right, product rule says first times derivative of second. What is the derivative of secant? Plus second, which is secant, times the derivative of first, 1. All right, for fun, let's factor out secant x as a common factor. And we are left with tangent, or x tangent x. And then what over here? Plus 1, yeah, don't forget your plus 1. Why am I having you guys factor this? Well, later we're setting this derivative equal to 0. It's easy to solve when you have the 0 product property set up already. When does this equal 0? When does this equal 0? Okay. Moving on. Well, let's do something fun. Let's find both forms of this derivative. So we have this function 1 minus cosine x over sine x. We could split this up and do 1 over sine minus cosine over sine and get cosecant and negative cotangent. Let's find both derivatives. Okay, first one. All right, there's our function. Let's find the derivative. All right, what particular rule or method do we have to use to differentiate this function? Quotient rule, okay. Low sine x times d high. The upper function is two terms. What's the derivative of the first term? 0. What's the derivative of the opposite of cosine? Just positive sign. Okay. Minus high d low, derivative of sine, all over sine x squared. Okay, sine times sine, sine squared, minus, it looks like we have to distribute. Okay, that would be negative cosine. And then we have negative times negative cosine times cosine, which would be plus cosine squared. Now what do you think? Oh, sine squared plus cosine squared x equals 1. Sweet, so that'd be 1 minus cosine x over sine squared x. Okay, so here's your derivative. Well, let's find the derivative the other way. Let's start with y equals CSCX minus cotangent x. So we're basically going to look at, okay, does it matter if we split it up, if we want to use the sum of difference rule or the quotient rule? Okay, let's say we do break this up. We see that there's one term in the denominator. We split it up. We simplify our trig functions so they're on base levels. We don't have any 1 over anything. Let's find the derivative this way. Y prime equals, okay, what's the derivative of cosecant? Yep, negative cosecant x, cotangent x, minus, what's the derivative of cotangent? Say again? Positive or negative? Oh, so it's negative cosecant squared x, but negative negative, so make it positive. Okay, and then we could factor out a cosecant for fun. And a lot of times I'll take a negative with, but right now I'm not going to. So that'd be negative cotangent x plus cosecant x. Okay. These two derivatives are very different, don't they? That's troubling sometimes when we're finding our derivatives, like on a multiple choice test. Say you don't split it up and you get this answer, but the answer choice is actually this one. Sometimes you either got to go back and mess around with this, split it up, simplify it, and then find the derivative. Or you could algebraically manipulate this too. Multiply by 1 plus cosine over 1 plus cosine, split some things up. You could get there. I mean, we could split this up into 1 over sine squared minus cosine x over sine squared. Does that, you guys see how we can get there? And 1 over sine squared, cosecant squared. And it'd be sine, cosine over sine times 1 over sine. Well, that's this right here, right? So two different options for you. Just know that the derivative answers could look starkly different. Maybe you need to manipulate this. Maybe go back to the beginning and rewrite your function. It's up to you. Your homework, though, I'm okay. Just find the derivative either way. All right. Let's say we have s of t equals something. So we're done with trig now for a minute or two. Let's go into higher order derivatives. We'll call this higher order derivatives. Higher order derivatives. S of t. This is actually called the position function. Most of the S of t will be the position of an object. You might say f of x equals the position of an object, but a lot of times we use t. Why? Because time is involved. Let's find s prime of t. What would that be? Okay. The derivative of position is actually velocity. What do we know about velocity? Well, if something's not moving, its velocity is 0. So if they ask you when is something at rest, well, set the velocity function equal to 0. What if they give you the position function? Find the derivative, set equal to 0. Okay. Let's find v prime of t. And actually, I'm going to move this over a little bit. V prime of t, which is equal to s double prime of t, right? Second derivative of position. And what is this? And this would be a of t. What would a prime of t, which is s triple prime of t, be? 6? I think they call this jerk, don't they? I think. I don't know. So here we go. I mean, it's basic, guys. One thing I have not shown you yet, though. Okay, I've shown you this. We've looked at this. But I have not shown you this. So after the first derivative, okay, this would be the second derivative with respect to x twice. The third derivative with respect to x 3 times. Okay, and the reason why it's like this is because it starts out, well, I'm just going to say it like this. The fourth derivative of y, because it'd be like taking d dx times dd, or of d dx of d dx of d dx of y. Okay, loosely we can say it that way. I'll be okay with that. So that's why the 4 is here and not after the y. Okay, we already did this. I introduced it already. We talked about position, velocity, acceleration. We have this notation. However, this is one thing to keep in mind. I didn't really highlight it earlier. When you are finding acceleration, you better say a of t equals the previous derivative, v prime of t. They will be looking for that. Okay, I will be looking for that. If we're going down the chain, find different derivatives, let's be very specific, very formal in our mathematics and writing things out. Communicating ideas, it's good practice. Okay? You already have this, though. Yeah.
When we are writing that, we have to also state that derivative of a is equal to the third derivative of.
Wow, okay. Well, if you go S of t equals that, then you say V of t equals S prime of t, you're good. So you already have this connection. So if you say A of t equals V prime, you don't have to say S double prime. It's already connected.
On the AP test, will they give us like a graph with no equation and tell us the derivative of it?
They'll ask you instances about the derivative. They'll say, well, is the derivative positive, negative, less than zero, greater than zero? Kind of like stuff I've already done. But here's the deal. You'll find on the AP test, mostly they're going to give you velocity. And we're going to have to go forwards using the derivative to find acceleration. And then we'll have to go backwards using antiderivatives to find the position. And that's part 3 of calculus, basically.